right, it is our last topic in chapter 5. Well, now we're going to solve these rational equations, right? Solve for x. So now instead of it being an expression, it's an equation. There's an equal sign. And how can we solve for x? So you can use a lot of those same rules that you used with fractions when you're solving fraction problems. So here, I was trying to sharpen this. I guess it's fine. Remember that you can cross multiply to solve. So I can do 1 times this. Well, that's just 1. Equals, what's 2 times x plus 4? I can just write that. Right? And now I know how to solve that, right? There's nothing too crazy there. Minus 8 minus 8 minus 7 equals 2 over x. Divide by 2, divide by 2. Negative 7 over 2 equals x, right? Oh, there goes my pencil. So all you have to remember is that cross multiplication rule for a lot of them. Let's try this next one. You try it on your own while I'm sharpening my pencil. It's pretty much the same, right? Cross multiply. We get 1 equals 5x minus 15. I'm just multiplying in my head. So 16 equals 5x. So x equals 16 over 5. All right, what about, let's start with word problem. Arthur and Cheyenne can paint a wall in 6 hours together. Cheyenne works twice as fast as Arthur. How long would it take Cheyenne to paint the wall alone? So she works twice as fast, and we're going to use x to represent the number of hours for Arthur to paint alone. So that's the thing we're trying to find out. So if x is the number of hours for Arthur to paint alone, we can say he paints one wall in x hours. Okay? So if we're saying one wall in x hours, we can rewrite that as 1 over x. 1x of a wall per hour, right? So we can paint some fraction of a wall per hour. And because Cheyenne works twice as fast, we can take this rate and just multiply it by 2. So Cheyenne, labeled with the C here, can paint 2x of a wall per hour. All right, so together it's 6 hours, and remember x is the number of hours. So if I add Arthur's rate to Cheyenne's rate, it should be equal to 1 over 6. They can paint one wall per 6 hours. Okay, 1 wall per x hours, 2 walls per x hours is what that means. So now when we're solving that, right, we can use what we know about adding rational expressions, because we can add those because there's a like denominator, so I can really rewrite it like this, right? Which then is 3 over x equals 1 over 6. And when I cross multiply, 3 times 6 is 18 equals x. Okay, but what is x? X, we made the number of hours for Arthur to paint a wall alone. So the question said, how long would it take for Cheyenne to paint the wall alone? Well, remember Cheyenne, she paints twice as fast. So she can paint a wall in 9 hours. All right, so now I'm saving some time here for this one, because I had to work this one out twice because I made those small arithmetic mistakes that messed up my entire solution, right? So we have this rational expression plus this rational expression equals all of this, and we need to solve for x. Okay, so first thing is I can't add these yet because they don't have common denominators, so I'm going to make them have common denominators. I'm going to multiply this one times x plus 3 over x. Sorry, not plus, minus, right? Times x minus 3 over x minus 3. And I'm going to multiply this one all times x minus 5 over x minus 5. So what do I end up with? Well, I end up with x minus 3 plus x times x minus 5 all over x minus 5, x plus 3. And it still equals the stuff on the other side. Now let's just distribute this. What do we have here? We have x minus 3 plus x squared minus 5x. And I'm just going to do this work here, so I don't have to rewrite the whole thing. And I know this, if I factor that, that's going to be x, what, minus 5, x minus 3. Okay, so now let's rewrite it with everything that's factored. So this, if I combine this, I have x squared, x minus 5x is minus 4x, and then I have minus 3 all over x minus 5, x, I wrote plus 3 here, it's supposed to be minus, equals 2 over x minus 5, x minus 3. All right, my denominators are the same. That's looking helpful. Can I factor this? I think I can, right? That's x minus 3, x minus 1 over x minus 5, x minus 3 equals 2 over x minus 5, x minus 3. So now I can start simplifying. So I know that can go away with that. What else? I don't see anything else. So now let's go ahead and we can rewrite it like this, just so we can see this step. All right, now we can cross multiply, right? So all of this equals 2 times x minus 5, right? Now I can divide by x minus 5, divide by x minus 5. That goes away there too. So I'm left with x minus 1 times x minus 3 equals 2. Okay, now I'm going to actually combine this. So I'm going to get x squared minus 3x minus x is minus 4x plus 3 equals 2. Which means x squared minus 4x plus 1 equals 0. Minus 2, did I do that right? So I got a different answer here. Minus 3. Did I do something wrong here? Oh, I see. You see when here's my mistake, and hopefully you caught it. When I factored this, x squared minus 4x minus 3, this isn't right because that's going to give me a plus 3. So, did I have a mistake here? X minus 4x, or x minus 5x is minus 4x. X squared minus 4x minus 3, it can't be factored, right? So I actually made a mistake all the way up here, because we can't factor it because those two negatives don't work out. And this is what I did when I solved it the first time, and I made the same mistake again, right? Those sign errors. So hopefully you noticed that when you were doing this. So I'm just going to leave that like that. So then what happens here? What happens here is, we're going to just erase this because I'm going to cross multiply from the beginning. Good thing I did this one in pencil. It's like you're in real class with me, because I would make these mistakes on the board, but then one of you would have caught it and told me I made a mistake. So this is where we're at, right? So here. So now let's cross multiply. Well, actually, I don't think I need to cross multiply. Why? Because this fraction has to equal that fraction, and our denominators are the same. So what does that mean? That means our numerators have to be the same. All of this stuff up here has to equal 2. So x squared minus 4x minus 3 has to equal 2. And now I'm at this same situation where I cannot factor it as it is. So let's subtract 2. Let's bring this 2 over. I end up with x squared minus 4x minus 5 equals 0. Now, can that be factored? Yes, it can be x minus 5 times x plus 1, right? And it has to equal 0. So that means x equals 5 and x equals -1 are two solutions. Okay, but let's go back and check, are any of these excluded because they're not in our domain? So I'm looking up here. So this is true except for what? X cannot equal 5. X cannot equal 3. And that's the same down here, right? Because when I factor that, x cannot be 5 or 3. So this x equals 5 is not a solution. This is what we call an extraneous solution. Extraneous solution. So once you get your solutions, you have to check, do they actually meet the criteria of the domain? No, it cannot be 5, so that's not true. And you can see that by, so first solving this equation here, we have two functions, this function and this function, and the solution is going to exist where those two functions cross, right? So I have put them in the graphing calculator. There is the left side of the equation, and here is the right side of the equation. So the solution should be where those two functions cross. And if we look, let's see, the left side of the function is blue and the right side of the function is green. So you can see those two cross here, and I can actually trace. Let's find where they intersect. Whoops. So intersect, and we want it to be with the blue curve and the green curve. Yes. Yes, 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 they intersect at x equals -1, so that is a solution. Now, if I go back to -5, you can see that they do not intersect. So that was an extraneous solution because it doesn't actually exist. They don't actually cross there. Okay? And let's try one more. Write this one down. So let's try 5. See if I can do this one without making any mistakes. 5x over x minus 2 equals 7 plus 10 over x minus 2. All right, so these all have a common denominator. Let's make that one have the same denominator. So I'm going to rewrite it as 5x over x minus 2 equals 7 times x minus 2 over x minus 2 plus 10 over x minus 2. So 5x over x minus 2 equals 7x minus 14 plus 10 over x minus 2, which is equal to 5x over, I didn't mean to write this 5 here, over x minus 2 equals 7x, and then -14 plus 10 is minus 4, all over x minus 2. All right, since our denominators are the same again, we know that our numerators have to be equal to each other. Now I can just solve that. All right, so x equals 2. That's our solution. Let's go back and check. Nope, x cannot equal 2 because it's not in the domain. So this problem has no solution. So the big takeaway here is after you solve it, always go back and check, is it a possible answer? Does it fit the domain restrictions? All right, I'll see you guys next time.